Leave it up.
Yeah.
You better be careful using an Esquire.
Yeah, right. You
Drink some more though.
You'll have the bar.
Hey,
That's fine.
the audio is live, by the
The only
way.
one is PE, professional engineer. No?
They will. Nobody knows PE is.
I'm not. I've never been.
Engineers do.
This is a thingy for Mensa though, not for engineers.
You're saying that no engineers have made it into Mensa?
Hell no. They're smarter than that. They know better than to join Mensa.
Oh, okay.
Oh, politics.
Hey, the mic's live. Hey, you fucking Mensa members, the mic is live.
We're starting in about 15-20 minutes, just in case you're out there, you people.
Yeah, let me see.
You're gonna get jerk out on it, you know?
No, because then it'll be too. You could probably add. No. That's enough. NDDDS EQC. What's trying to call it? They just make no letters.
Yeah. I really try to do their life.
Oh, I can start from father. Father is never a word, right?
Well, you're already it was fine. It's great. I'll take the money. I didn't, whatever.
Nice again. What? No. All right.
Oh, and how, those two.
What must you learn else, man?
Yeah, it is a lot. So, like the one that I had, Mandarin and DevOps. That's fine. They'll work on that.
Yeah.
Stupid. Yeah, it's tough. Like there's a lot of movement going on, but there's yeah. Right. You're an engineer. They'll pay a lot. They'll hire you guys.
While I was there, like, we called it downstream. There's some relevant service.
You look hard on my husband. That's the thing, it's a position to be gay. You're okay. ridiculous.
Oh, so it's not even.
Oh, you're gonna be going by Reverend, you gotta have something in there. Doctor, PhD, Dr.
Oh, he's a doctor.
Yeah, but there's a theology degree.
Get a job.
Astronaut.
No, it's good.
No military? Huh.
Oh, crap, you're right. You're right.
L. Ron.
Probably ask me.
What do you
Yeah. Can you search? Okay. That's why I put it in the lead too. Some of those are always in the military.
Yeah.
Placement authority like that.
There you go, how's that?
Yeah, that's standing in the middle of the guys above you and the guys below you.
I was in the Air Force, but I know what kind of sergeants are all about.
Oh, is it?
Yeah,
It should be
Oh, really?
IECCIE.
Come on, guys. Yeah.
Look around at space, huh? They can always put presented by on its own line, and then you get a little more space time.
Yeah.
Or
Actually, presented by on its online, I think.
Yeah, it's right in there.
Really?
All right, last edit. Last edit of the day.
That's what they all say.
That's what they all
Just
say.
like, is that like the last bug?
No such a thing as a lie.
Yeah, well.
What's up?
We're a day late for that.
yeah, whatever.
I'll never do
You're
it.
probably not old enough to remember the IBM commercial about presentation.
Me, no, hell no.
I don't remember those, but I'm sure it's not because of. I probably wasn't paying attention to that.
They, you know, IBM always tries to do mind share. Commercial. When you think of a product, you think of IBM as the seller. And so they've got this poor guy who's making a presentation, and he's using IBM.
All right, that's it. No more edits, people. Okay.
Yeah.
Done.
Foil printer.
Yeah, I made the mistake of leaving right after lunch one time.
If you want to find any more of Mr. Goldstein's credits, you're just gonna have to go to mensa.org.
Basically.
Look him up in the registry.
Well, that's what people are supposed to be using the road, I guess.
Whole up system, you know, you can get yourself a 4300 and this printer.
That's where we're leaving, you're like, breakfast and gone.
Yeah, he didn't
Have
have
everyone
PCs yet.
It's been a while.
So he's made it easy. Hopefully the commercial is he's finished. He gets a call. Okay, I'll change that.
Real vacation.
So it takes, next thing you know, he's taking it into his boss and coming back down. So, you know, all this, they're talking about the productivity that this guy has gained by having this, made all his presentations instead of hand plastic by himself.
Oh,
I'm going, yeah, that's what I have to do. It'll end up being revision after revision until he finally makes the presentation. And the guy also wants one more revision just to go to the presentation. He won't be able to make it. Because, you know, that's why it was.
You gotta fast forward.
Oh, no, because you're over there.
The foils, you know, you spend a whole week making the foils and you go in.
But don't leave that running.
There's always got to be some
You
change.
don't want too many streams. Too many streams
See,
spoil.
that's why you need to switch to NDA. You only switch once.
Even if they're in the room.
One of these days
The
I'll.
wireless router will split it up.
Yeah. No, I don't, but I'm sure you'll.
Just buy it, just buy it, yeah. That sounds like.
I'll just try to get you more copies.
Yeah, there was only one difference between SQL and SQL.DS. That was the thing. You make comments.
My husband lost
Some
his
special
lead.
comments. Don't care. Everything else was exactly the same because it was mathematical. hanging out in one of this. So it's my congregation. Not your idea. Carry the cachet of not selling it. Selling the cachet.
Huh? Well, I forgot my other laptop, so that's hosting the.
All you want him to do is write.
This guy is hosting the meetup. I want to just get another one where I can monitor its YouTube stream. So that's the Google. Got the Google Hangout. Yeah. And theoretically, like you could have other presenters there. I haven't really worked out the whole sound thing.
Yeah. I have a laptop. You need to use a laptop.
No, I'm just gonna. Well, I can monitor the YouTube stream from my phone. My extra phone, work phone. And I was just looking to see if there was a YouTube app on this thing.
Yeah, when you tested it,
But it's going good, actually. How you doing, man?
Just started the consulting.
Good, congratulations. You know we should do lunch or yeah, I'm right down the street.
Yeah, that's why I got a little BDB. Yeah.
Good. Hey, yeah, how about we do another Sea of Mention talk? It's about time. Yeah, like 5 years ago. Well, I think the last time we did was we did the 3.
Yeah.
Did you hear about John Willis who sold his business?
Again.
Yeah. No, but this one I think he nailed it. Here, Steve.
I'm sure it's
Willis? Actually, I could hit him up. That's not a bad idea. I mean, but he's usually comes out for sale. So there may be another DevOps, a breakout DevOps thing. So I wouldn't want to just burn him out for a UUASC meeting.
Oh, okay, right.
It's kind of special.
Yeah,
But he would do it. All right, if I can find one of these that works, I'm golden.
yeah, we were there. Thank you so much for keeping all this going.
Huh?
Thank you so much for keeping all this going.
Yeah. Hey, I got to entertain myself.
Yeah. Oh, it's a Windows based one.
Doesn't seem to be playing for me. Here we go. Maybe this is it. So Steve, you're picking up the stream on your phone?
I was earlier.
Okay, you got audio too? Freaking Android. But yeah, we'll kick off in a little bit. You have an Android phone? So how do I find the YouTube app and all that?
Whatever. I mean, you can get me too.
Oh, there we go.
Last training I did,
You broke it. Sort of. You broke it. How's it going?
No, actually, I'm in pretty good shape. Streaming, I just, no, the iPhones store the screen. Usually I bring, I have a second, bring 2 yeah, sometimes you grab that. Well, this is work phone.
Thank you. Work phone, huh?
Hey.
What? Because I work with here, I'm like, what do you mean?
No. No, usually. Yeah, hey, no, actually, just make my request to go to DMC World. Where they have it. Vegas. Okay, guys, congratulations. GoDaddy went public. Stick around for 7 minutes. Oh, that's right on.
Downstairs.
Yeah.
Justin's like saying, because we had to find out like what was.
Wow.
And they had this big problem coming through the shop. And the kid was there. So, 10,000. We're going to do this.
What I get?
After the anniversary, that's what I'm going for. It's like more than I had before.
When did you go public? Okay, so technical.
He's the only one who knows what he's doing.
Yeah. Hey, that's good. Good.
Yeah.
Oh, it's less than
Yeah.
And I was like looking at it,
Yeah.
like,
Where you working at?
oh, okay.
Oh,
It's kind of fun for everybody. It was like, oh, like,
yeah.
It's funny because I didn't see that shit out of laptop. So that was like, I know what he's talking about.
Courtesy of Q. What's that? I miss showing the people all about the nice spread we got here.
And that's the one thing I like.
Hey man, how's it going? Hey, neither does Mr. Goldstein. All right.
Tomorrow you're going to today, yeah. Basically my new mantra is I can do it. I feel like we were doing combo before. How are you doing? You're going to be, they want to get us used to the point, then they can be like, this is too deep for us.
Like 3 years over.
Like, and then once everything's free, they finally get our team, because, like, everybody gets something. So, yeah, well, we do that. Yes, which is kind of frustrating me in a way, because it's like, I'm more busy to care about things, and I have less points. And so they don't realize that we see a huge distinction between meaningful and meaningless points. Yeah, they just see points. But they do Jerry and break it up. Yeah, I hope not. They see meaning. They still, I think management still sees meaning. It's like, why do we talk about it? It's the only place. And it doesn't matter. It doesn't matter because they know it doesn't matter. All right, they just want to make sure that we understand how to read things down. They don't understand how to understand.
Oh, yeah. I got some, pretty much what I want.
Yeah. All right, hey everybody, we're gonna get started. So have a seat. Okay, welcome to the Unix User Association of Southern California, April 2015 presentation. We'll be starting in a minute. Just some internal business and announcements. Thanks for coming down. Thanks to Carolyn and Q for hosting us. So first, a little bit about UUASC. UUASC is one of the longest running Unix Linux technical meetups, or it is the longest running Unix Linux technical meetups in LA or Southern California. We have 2 chapters, an LA chapter and an Orange County chapter. The OC chapter is a little dormant these days. I think, is anybody here, is there anybody new here? Uh-oh. But basically, for those out there in internet land, if you'd like to be a member of UUASC, the main thing to do is join the mailing list. So if you go to UUASC.org, our website. There's some information about joining the mailing list. We have 3 mailing lists. General mailing list, which has all kinds of good discussion about Linux, Unix, whatever related topics in beer. There's also the announcements mailing list, which is just announcements of presentations or special stuff. And finally, there's a jobs mailing list, UAC-jobs, which has, you can post job announcements or if you're looking for work. It is a moderated list, but you don't need to be a member to post to the list. If you have a listing, you can send it to UAC-jobs@UAC.org, and if it's a Unix Linux related job in Southern California, it'll get passed on. Okay, UUASC meets the first Thursday of the month. Usually, unless there's some issue, like I think I might be out of town the first Thursday in May. But you can, if you're a member of our mailing list, you'll find out about it. We also have the meetup site as well, which usually has the most up-to-date information about the presentations. I'm always looking for speakers for UUASC, so if you're interested, you can post up on the UUAC mailing list or email me directly. I post somewhat frequently to UUAC. So, and just send me a little, maybe a title or a brief description of what you'd like to talk about. Like I said, we're always looking for speakers. But next month, we're going to have Ned Lerner from Chef talking about Chef. At least an introduction, and perhaps also the work they're doing with Chef Zero, which is, I guess, a refactoring of their Chef standalone client that a lot of people are interested in. He's at the Chef conference right now, so he'll probably have a lot of information about all the stuff happening there. So that's next month, and I have some other potential things going forward. But that's it. So hey. Q has been kind enough to host us here at UUAC. So let's have Carolyn tell us a little bit about exciting things happening at Q.
Hi, everybody. So I'm Carolyn, in case anybody hasn't met me before. I work here at Q. We are an IT and digital talent firm, so we do help out anybody who's looking for a job or looking to hire people at their current jobs. Even if you're just looking, what's going on in the market or help with your resume, anything like that, always happy to help. So I'm in the back over there, and so is Wendy and Sevan also in the back. So happy to help you out, give any questions, anything. Happy to help you afterwards. And other than that, I also run a meetup. It's called Linux-LA. We're having the next meetup in a couple of weeks on the 20-something. It's the 23rd Thursday. Yeah, it's a hands-on intro to C++. So anyone that has been looking to learn it and hasn't, so it's meetup.com/LinuxLA. So go check that out, and always looking for speakers as well. Other than that, we have fancy new trash cans. Yay!
Please use them.
Please use them. If it's recyclable, put it in the recycle. Because
and don't waste water.
Don't waste water. Seriously.
25%
everybody
reduction.
See, you gotta reduce your water by 25%. So share with a friend, all that stuff. So thank you for coming, and see you next time.
Cool.
Thanks, Jordan.
Yeah. Thank you, Q, for hosting. It's pretty easy to do stuff here. Oh, hey, Rick. As far as does anybody have any other meetup announcements? I know Rick, you wanted to mention the LA cloud computing.
Yeah, next Tuesday, April 6th, I'm engineering room so that we have 8 minutes of co-driver cloud campaign. Pivotal cloud parameters, we do the demo of pivotal cloud parameters.
So for you folks playing along at home, that is the LA Cloud Engineering Meetup is next Tuesday. Yeah, let's do the South Bay, right? Or El Segundo. Yeah, and then there's a good meetup out. Oh, and that reminds me, after the meetup, we'll go over to across the street to one of the fine dining establishments. So you're welcome to join us for some food and drink. and further discussion on named data networking or something else. So with no further ado, oh wait, I forgot. We're double booked tonight with the Greater Los Angeles Area Mensa meetup. And we're going to start with a short presentation by Gunnery Sergeant Reverend Tonto Goldstein, Esquire, PhD, MD, CCIE, IE, NSA, BYOB. So, and then Steve Rieger will come up and talk about named data networking. Take it away, Tonto. Rabbi.
No, he's a reverend.
Oh, I thought it was multi-faith.
What? No, I'm not going to go through the whole presentation. Pretty much it's just a history. You want to read it? All about April Fools and where it came from. It's actually a presentation I put together that we are running.
But we're Mensa members, so we already know this.
Yeah, you know. But I'll put it in the same. I'll put it in the same share as the actual presentation, so you guys can use this. Screw with people. Feel free to do that. I'm going to dive right into the presentation for. I'm not used to this. So NDN is actually, it's called named data networking. It's been introduced and written about as content-centric networking for many, many years. First proposal, I think, was in the early 1980s. In 2006, a couple of guys at UCLA, I don't have the exact names, but if you go to the named data networking website, it's all listed over there. A bunch of guys at UCLA and a couple of scientists in Japan actually got together and started doing this. This slide is about 6 months, 8 months old, and I'll show you an updated map of who's out there working on the NDN project. But I just wanted to put this up here just to show you guys that it actually has traction. It's not a backyard project. It's actually live and it's in the world. I mean, some of these UCLA, UCSD, University of Michigan, University of Memphis, Colorado State, Washington University in St. Louis.
Hey, that's my Final Four bracket.
All right, presentation over. But it has. In November of 2014, Cisco dumped a ton of money into this. Currently, Cisco is involved with this. They are backing this project. And we'll go through and I'll try to explain as good as I can why. DARPA is backing it. ISC over at USC is backing it as well. So it has the backing from some
ISI.
Internet Security Consortium.
Oh, okay.
ISC.
Okay.
I don't know why it's but Internet Security Consortium is backing this.
I think he was thinking of Information Sciences
No,
Institute. That's also
ISC.
down there.
People that write all the people that approve all the RFCs.
That's ISI.
That's ISI.
Okay, sorry.
They're
The
back.
RFC editor is at ISI, which is part of USC, which is at Marina Del Rey.
Okay. So the outline is we're going to go through the basic concepts, and this presentation is going to jump around a little bit, otherwise it's going to get a little boring. But it's going to flow through beginning to end. It's going to go through the concept, and we'll show you how NDN does stuff better than TCP or better than IPs with TCP, with DNS, and all that garble together. I'll present an overview of NDN development. So some examples. We'll actually do a live demonstration. I'm going to browse the web using NDN only without any TCP involved at all. So the core idea came from modern communication consists of requests for named data. I'll go a little more in details in a minute. Today's networks are host-to-host based, meaning it's device-centric. The device talks to another device is what we call the internet today. Back in 1971, it was a great idea because we had, two universities that were talking to each other. Today, my cell phone wants to talk to your cell phone over Wi-Fi. It's not practical. It's just, or if the NFL wants to stream Sunday afternoon football game to 1 million people, or however many people watch NFL or NASCAR or World Cup, it's not practical. For every end user, you create a new stream for it. So NDN is a general purpose network protocol. It is not an application. It's not necessarily a layer per se. It's not security. It encompasses most of everything that I just mentioned, but the idea is that it's a protocol that you add on to. It's a set of foundations that you build on top of. Content-centric networking is where it came from. And the beginnings of it is very simple. One of the reasons it's so, that's supposed to say no. There is no NAT traversal. There's actually no address space exhaustion. We never run out of an address space. What's that? NAT, network address translation. We don't have to do any of that with content-centric network. You don't have to do any NATing. We never run out of space, address space, IP, IPv4, IPv6, you want to call it. You never run out of space. PWWNs, all of that stuff. You'll never, and we'll go through details. We'll go into details in a moment. There is practically no latency, and the overhead for bandwidth is less than 10% if you run NDN over TCP, which you can do, which is natively allowed. Networking is in mobile scenarios is easy because we're not going to end-to-end. The data is your network. So when there's data out there that advertises to the world what's going on within the network. So in essence, the more data you produce, the more data that exists, the better the network starts performing. So a high-level overview of NDN versus IP/TCP, the way we see it today. Like I said, the NFL or YouTube, everybody gets its own stream. With NDN, it only streams it once to each of your ISPs. The reason it streams it to each ISP, he actually doesn't stream. He just produces the data. When an end user comes in and requests it, he looks at the first hop. And he makes a request to their first hop. If the first hop has data, he gets it from there. And it keeps going back up all the way till the producer. Chances are the producer already produced the data. And in NDN, we do away with the concept of devices. There's a producer and there's a consumer. I'll go into that in a minute. But this is how NDN data flows. Yes.
So the set of requests all contains the identification of the end recipient.
Was it what?
The end recipient.
No.
Or
We only communicate a single hop. We will never communicate more than a single hop. Yes, sir.
So this is for live streaming data the way you'd use multicast, not for stored recordings the way it would be on demand, the way you would like with the CDN.
Correct and incorrect. And I'll go into that in a little more detail. The whole concept of multicast kind of goes away. It's still built into NDN because it's really hard to rip that concept out. But again, this is data and it's also the network. So there's no more, you don't advertise that a packet is coming. The packet goes out there and it'll keep bouncing around for anybody to pick it up. Okay, so bear with me. It's going to be a little confusing, and just to give you a forewarning, I am fully expecting to come back in about 3 months and do a very technical deep dive in this. I'm going to try to do a 1 hour overview of this because it's so far out of left field.
So you say it's a bit more like P2P TV?
You're still using a single stream from end to end on P2P because it runs over TCP, right? We're not doing that. Every connection on P2P, I request data from whoever has it, and he sends it to me directly.
Right, but what it has in common with multicast is that the source streamer only needs to be streaming out one copy.
Yes. In that case, in that sense, yes.
but then there's only one viewer, right? So
On
in a
P2P, there's only one
right.
viewer.
Or if the one source was doing multiple streams, you'd have to copy it out
Multiple times.
and number of viewers. Yeah.
And at the end, remind me to give you 2 live examples that are in test today. But this is in essence, this is the current networking, and this is proposed. Browser, chat, email, but none of that's going to change. What we change is right here in the middle. is how we go from the individual to individual is what we change. Individuals to individuals will still have to communicate. However you come onto the network is up to you. We don't care. And when I say we, I'm not part of the official NDN development team. Only people that are only scientists and engineers are. Official university people are allowed. You don't have that .edu email address, you're not allowed on. I've contributed.
Oh, it's like Facebook.
I've done some bugs and all that stuff, but I'm still an NDN guest. I don't have an official NDN. I'll show it to you guys later. So when I say we, I don't mean to imply that I am part of the NDN team. Okay, I'm involved with them on the mailing list. I contribute to the code, I work on bugs and all that, but I don't speak for the NDN team at all. So what we're trying to do with NDN is replace the actual communication that happens once data leaves your device. How you connect to the network is up to you. You can still use TCP to connect to the NDN network, or you can use something called NFD, name forwarding data. That's a replacement for TCP and IP. For TCP, NDN has IP built in. You had a question?
Yes, it's really, since I didn't understand this stuff, I want to ask what I didn't understand. If you have a tree
Source.
from the source, yes. But really, what I'm, as a user, I'm looking like, I have a tree coming up from the user. This sounds like a lot of redundancy.
That's the way networking is built today, though.
Oh.
That's the before.
That's the way it currently exists in the IP world.
Well, maybe
We have two types of we have two types of packets in NDN. This is a brief overview, and here let's go into a little bit more detail. We'll go through this. We have an interest packet, and we have an actual data packet. An interest packet, for the most part, is when you go to, say, youtube.com, when you request data, we call it an interest packet. But I don't send it, and we have to rethink the concept here. I'm not a requester. I'm not going to request data from youtube.com. I just type it into my browser, and I'm interested in a piece of data that resolves to currently, because DNS, I'm interested in a piece of data that resolves to www.youtube.com. I don't request the data from YouTube. I request it from my next hop, from the router or the switch, or whatever it is, that's immediately above me.
Kind of like how DNS resolution works.
Very similar to it, yes. So I request it from the next hop. If the next hop doesn't have it, he forwards an interest packet up and to the right and left, to whoever's connected to him, and so on and so forth. That's why chances are that once the NDN network is flooded with data, chances are I'm never going to go upstream to the actual producer, which is youtube.com. So NDN rethought the whole concept of end-to-end devices, and what they came up with is that your cell phone is considered a consumer. It's not a device, it's the consumer. You will consume data. Yes, when you stream YouTube, like he's currently doing, he's a producer. But YouTube is always going to be the producer. Because people are rarely going to, YouTube is rarely going to request it. Yeah, request advertisements and all that. But in general sense, the people that watch and browse the web are considered consumers, and the people that produce data are considered producers. So when you do a request for data, the interest packets that come from the consumer side, the data packet gets produced. It doesn't get produced just for you. The data packet gets produced because youtube.com produced data. And it doesn't know who requested it, just know the next hop down requested.
I'm still like not there. Okay, so I send out these things, and one interest packet, says, yeah, how about all the other interest packets that went out for my request?
You only send out a single interest packet.
So it only goes up one channel.
It only goes to one hop. If it doesn't exist there, the next step is send it further up. You don't. In
So
all
only
honesty,
one gets sent out.
you do not know how to get. The consumer has no idea how to get past that single hop.
All right, I'm not.
So is this an anonymous network? Is there anonymous?
We'll get there in a
Okay,
second.
good.
The NSA
Oh,
does not
boy.
like this, very
Yeah.
much so.
I noticed that
But
right
we'll
away.
get
Oh,
to that.
I want to trade my Dogecoin on here.
So anyways, an interest packet is a data naming query. What I want youtube.com. Nonce is a unique identifier, every packet that I send out is going to have a unique identifier that I come up with, random ID, however I want to create it. Selectors to help better match interest in data, scope and interest lifetime to help guide packet content data. So if there is a expiration, the producer has a right to put expiration dates on his packet or expiration times. So I will put in that I don't want anything past. If somebody's live streaming music, I'm going to say I want current date and time.
Right, yeah. Or if you're looking for a sporting event, right, you want the fresh data.
12:37 p.m. and yeah, so on and so forth. And data packet content is of arbitrary data size. In all honesty, it can be from 8 bits to 500 megs. Single packet. However big you want. Well, 500 megs is conceptual limit. But really, if you want to make general frames that big, TCP, you can put it as big as you want. And there's a signature, and we'll go to encryption a little bit later. But there's security inherently built in there. Every packet that gets sent out or every packet that gets produced is encrypted and is signed. There's a pending interest table. Now we start getting into what goes up upstream. The previous packet is handling done by the node. PIT, and see there. Okay, this is not. We'll go into more of this in a minute. This is the routing I was talking about. So when you send an interest upstream that I want YouTube.com, the node that's upstreaming you, that router, all he knows is you received a request from downstream, and I don't have the data. Now, forwarding information base is the routing that happens, and I know where to send the request, the interest request I got from below, where to send it on to. This is what we know today as a router, software layer, that is. All the information that it needs to send packets for interest upstream is contained within an FIB.
Is this like ATM where the individual routing nodes don't know the whole design of the network? They only need to know their neighbors?
We don't know design of a network. All I know is what data I have and what data exists above me and to the right and to the left. I don't know who's there. I know which data exists.
So these nodes, are they caching the data or just forwarding?
Everybody just forwards. You could cache if you want, and we'll go into that later. Like I said, this is going to be more than a single presentation. I want to stay as high and ask questions, but I'd like to stay as high level as possible because I'm going to cover a lot of information tonight. So content storage is kind of, Dropbox. Take Dropbox, take away the disks, and dump everything in TCP. This actually works, meaning you can use the internet, today's internet, as a hard drive. And I'll go into a little bit more of that later. So we cache data locally as much as possible. Within it, there is a time frame. So if you have 1 million people are streaming the NFL, chances are that top level at att.com switch is going to cache a ton of the game as it comes through. It's going to have expirations of 90 seconds or however long the stream is going to be valid for before it gets updated. But the cache is going to be there because that's part of our protocol. We want to minimize traffic as much as possible, so we cache as much data as low on the network totem pole as possible.
You keep 90 seconds so that you can rewind.
We keep 90 seconds because that's what I decided to do. That's not built into the protocol. That's up. Whoever produces the data will put an expiration time. So Flickr.com, as it produces all those images that we all upload, is never going to put an expiration time, right? Because all those images are going to be there forever or until you delete them.
So this is not just for streaming video?
No, absolutely not.
No, yeah.
I'm just using streaming video because that's the easiest way to understand the difference between TCP and MDM.
90 seconds makes sense. There's some poor sucker down the line that's going to be buffering a lot, and so hopefully you want to make sure they're going to always kind of dragging a little behind.
Yes.
But like hopefully they can catch up.
That said, if the poor sucker that's buffering has his next door neighbor who's on the same ISP as him that's not buffering, he's going to get his packets from his next door neighbor. So there's never going to be buffering. Not necessarily. If one up doesn't have it, one up knows that the next door neighbor is watching the game as well, and the next door neighbor will send the packets to him. The one up knows where the data exists. He doesn't hold any data. He knows where it exists. And
so
the redirect
between him and his next door neighbor?
doesn't have to be. It goes up and down.
That's what I know.
Yeah, no, we're not going to start connecting. But the point is that we push data as low to the consumer, to as close to the endpoint as possible. That's the whole concept of NDN. We don't want to have to go all the way up to YouTube or Flickr or whatever it is to get data. And again, we'll go into more detail as we go on a little bit here. Allows network to become more data focused. Actually, it doesn't allow it. The whole point of this is to make a network what a network is supposed to be. A network consists of nothing but data packets flowing around. And that's what a network is supposed to be. It's that the data itself should be the carrier, should be the advertising, should be the signature, the timestamp, who produced it, who it's going to. All of that stuff should be within the data. Unlike TCP, where you send out the 3 cars in the front and the whole train, and the 3 cars in the front are pulling all the data behind them. We're trying to eliminate all that overhead, no acknowledgments, no latency, no nothing. It's quicker fetching of data for consumers. The data architecture can vary first in, first out. You can write, as a producer, you can set the rules of your data. And to take it another step forward, you can have, for a CDN would be a bad example. But say you, what's that? CDN, content delivery. But say you have, I'll show an example, a live example a little bit. Say you have a server over there and a server over there. You can have half of a video over there and half of a video over there, and the end user will never know the difference.
Like BitTorrent.
Kind of. This is another one for the algorithm. I'm not going to go into it much, except for when we talk about a face, we're talking about an interface. But an interface is a little bit different because we don't care. It's not necessarily a socket. It's not a physical outlet. And I'll show you an example that on this laptop I have NDN running, and I have, I think, 5 or 6 faces. For different, I have a UDP, I have a TCP4, TCP6, I have an actual socket connection to NDN. So this is how we do naming. This kind of, we're piggybacking on a DNS concept. It works amazingly well. As we all know, it's really hard to, it's easy to spoof DNS, not easy, but if you get stuck in the middle, you can spoof DNS, but DNS is an amazing concept, and the idea was well executed. So why not keep it? We're not trying to break the rules. So you have part.com as videos, widget.la.mpeg, version 2.s1. Part.com videos, widget 8, mpeg-v2. You put in a timestamp, and you put in S2, S3, whatever you want. All of this is up to you. However you want to name your data, you can name it. I trust this because when you become a producer, or when you turn your computer on or your server on and you bring up the NDN protocol, you will produce data. But if you did not generate a key and send it out to the world, nobody's going to trust you. People can read your data without you producing it, generating a key and signing all your data. But I will not trust you. Because the whole concept of this is that each packet that you send out is going to be signed and encrypted by you at some level. You don't want to encrypt it, don't encrypt it, but at least you're going to have to sign it. You're going to sign it with all of this. This is going to be the name of the data packet, and this is actually going to be the data that resides within the packet. And it's going to be part 1, part 2, part 3, part 4 of the same video. That's how you sub it. And you can keep, this is pretty much unlimited as to how long the name can be.
Is there a CA? Is it using the standard Internet SSL cert?
There's no SSL cert. You create your own certificate within the, and NDN has a certificate generating mechanism built into it, and it's got 3 different types.
But there's not a certificate signing an authority and
There is, you produce your own certificate. You send it out with your data. When somebody sends out an interest packet for www.youtube.com, the first thing he receives back is a certificate. If he accepts it, there is a central repository where you can download certificates so that if somebody forges one, they can't hose you. And that one repository currently exists for all of the universities, but you know, I do have a certificate up there.
So they function like a CA.
There's a clearinghouse, it's a trusted clearinghouse.
This sort of sounds like the Etsy hosts file circa 1981. Like.
Kinda, yeah. You can see that. All right, so NDN CCN uses a name prefix instead of an I prefix. Call yourself whatever you want. I don't care. because I don't have to remember all your host names or all your addresses. All I have to do is go one step on top of you, say you're parallax.com. We're UUASC.org, right? UUASC.org can have hundreds of thousands of nodes and addresses below it. I don't care what they are, because all packets go, actually, and then the end packets don't go to, packets always come from. But if all my data that I'm getting comes from one single location, UUASC.org. I don't care where it comes from past that, because I will never send any data past the domain name. The top root of UUASC.org knows what's below it. And chances are he'll never advertise it unless he has very specific reasons that he wants to create a route between one of his underlings to UCLA.edu. Then he'll make a route between those two locally. And they will trust each other and they will communicate. But I can go back to that whole tree thing. The nodes below do not know really what lives above unless it's in the same tree, unless it's part of the same kind of domain. Make sense? Yes?
Is the fact that it's running over IP now a fundamental part of the design, or is that a temporary convenience?
Oh, this would never fly if it would not work with IP. It's that simple. There's too much at stake. Nobody in the world is going to come up with a protocol and saying, IP, you're useless, use me instead. It's just not going to happen.
It's always going to run over IP.
It can, and it always will. The whole point of this is don't run over IP, because this is a whole rethinking of how data doesn't get sent, data is only requested. Meaning you also can't do any DDoS attacks. It's impossible, because your packets are never going to go past the first hop. Because all you can do is request data, right? So when I send out 1 million requests for data, all of those packets are only going to go to the first hop, and the first hop is going to respond with the data that I requested, and I'm going to take myself down.
What if they're for different URLs?
Then knock yourself out. You're going to get all different URLs, but you're not going to take down a single server, right?
As long as serving up that stream doesn't require more work than it
That you're going to take up bandwidth. What you're going to do is you're going to take up bandwidth. But we have failover built in, and we'll go into that shortly. Somebody over here had a question? So again, when we do routing, everybody knows what, he would know what exists everywhere, but D does not know what exists on B. E doesn't know what exists on B or A. F would not know what exists on D or A. So I only know what exists one hop away, that's it.
When you say you know what's on there, you mean you've got the directory of all the valid?
I have a directory of what we know today as DNS entries. And because DNS entries actually contains data, if I know what the data packets are named, I know where the data is located.
So you just know about the domains you can get to through that link. You don't have the list of the entire, all the resources.
Not domains, but I know which data packets I can get to. And because I know which data, I have the address, meaning I can go and grab the actual food that exists within that address, or the food being the data in this case. And NEN separates the objective of retrieving, and it specifies how to do it. I don't care what you want. I will tell you where to get it. And the only thing you can do is move data this way. Again, I send an interest packet. I send an advertisement out there, or a letter in the mail, or a fax, or an email, or a smoke signal, whatever you want to call it. It doesn't make a difference on what method you use to get your interest out there. Again, it can be TCP, it can be UDP, it can be a socket connection, whatever you want. I send an interest out there, and somewhere here the data exists. I don't have to necessarily go here unless the data has never been released. The data has been produced on this, but it's never been produced on the network, then I'll end up over there. But all I do is I send it to my closest hop, whatever the case may be. And then somewhere in here, the data is going to come to me. You can't send data. That's the major difference. You can't just send data across.
One way.
Yes, and it always will be. This is supposed to be earlier, but I go back to the whole cell phone concept. It's difficult to disseminate data to a large group of users with today's technology or today's networking structure. mobile users whose addresses change, they have a really hard time with IP-based networking. If you're streaming something and you move from cell phone tower to cell phone tower, you're going to get interrupted. There's no two ways about it. With NDN, you don't. Because I don't care what, I don't have an address anymore. All I'm doing is I'm connecting to data. I'm not connecting to a network. Again, it's hard to understand, as I know I'm probably confusing some of you, but we'll get a little more detail.
But the reality, though, is that people will listen to streams on their cell phones as they're driving home.
Yep.
But so there's just buffering hides some of the interruptions as we move between.
No, the reason streaming buffering has interruptions when you go from tower to tower is because you're getting a new IP, you have to start a new stream. That is not the case with NDN. Because I don't care how you connect to me, the data, Pandora is on the network already. The data that you seek, the Rolling Stones or the Who, the Doors, or whatever it is on the network already. How you get to it is up to you. So you go from tower to tower to tower, yippee-ki-yay. You're gonna get this, you're gonna get the packets are just gonna follow you as long as you connect to the data network. Because the data exists. Again, the current network infrastructure cares how you connect to it. Whether it's IPv4, IPv6, SSL, non-SSL, all of that stuff comes into matter, right? Going forward, we don't care how you connect. We took that device-centric approach and threw it into the trash. And we said, I don't care how you connect to me. I have data. If you want it, tell me you want it, and it's yours. And I will send it to you over any means necessary. This one here? Yes, okay. So today's internet traffic, and I'm going to keep reiterating kind of the same point a couple of times. Today's internet traffic is content driven, as we can obviously see. The problem is the networks weren't designed for that. Underlying communication is destination driven. So I will send data at all times. I will send a request for data, and the target over there, wherever I sent the request, is going to send me data. Perfect for DDoS, right? Perfect for, say, DNS spoofing or man in the middle or whatever you want to call it. All I have to do is I have to insert myself in the path someplace, interrupt, and answer that request, and everything below me believes that I'm the person because I was in the middle and I answered. Well, he doesn't know that I'm in the middle, but I answered him as Google.com and bingo, or at bankofamerica.com or whatever the case may be.
Unless you use SSL.
Unless you use SSL. The problem with SSL, and I'll mention this because you brought it up, and the problem with SSL and all security today is it's kind of like a gated community. You have everything on the outside, and within my data is. If somebody pokes a hole one place, everything else it's like a barrel, you make a hole, everything comes out. That's the problem with today's security. So NDN does that completely different. Do it, again, please no stoning, no smacking, please. Take away your firewalls and eliminate SSL. Encrypt all the data. Sign it as the producer and encrypt it as the producer. You can send it out into the world. Nobody can read it or decrypt it unless you give them permission to. And how you sign it is completely up to you. Whatever key algorithm you want to use, knock yourself out. It's just like PGP, right? Same concept. But the difference is you can encrypt every packet. So conceptually speaking, you can have a whole slew of Oracle rack servers or SAP servers sitting out there on the Amazon cloud with no firewall and use NDN as a communication protocol between the servers, and nobody's ever going to get into it.
That's because of IPsec as well, right?
IPsec, you're still using overhead. The whole point is we're trying to get away from TCP overhead. I personally, I'm starting to run a test plan for, I want to go with, say, I want to use 22, 25 Oracle rack servers. Problem is you can't do that today with TCP because the latency between them, they're all going to go out of sync and all that. So my goal is to bring up 22 to 25 Oracle rack servers and use NDN as the inter-chassis or whatever you want, the cluster communication. I want to see if that's possible. Because that's where the implications come in. When you're talking massive communications requirements, such as hospitals, such as infrastructure within a building. Just one of the reasons behind in the end is so that devices can talk to each other. We'll get to that in a minute too. Anyway, so.
These guys raising their hand.
Yes.
Touching this next.
I'm curious about why encryption is mandatory, but it seems like it might be unnecessary overhead for a lot of data. It's not sensitive.
It's not needed. You have the option to encrypt your packets.
Okay.
It's absolutely up. You must sign all your data that you produce, so we know who it came from. But you don't have to encrypt it. Yes, sir.
It seems to me, and it's just a feeling I get from this description, that it seems like it's putting a bigger burden on the intermediate nodes.
Yeah.
Like YouTube only has to send out the video once.
Mm-hmm.
Everybody else has to keep part of the resource dedicated to YouTube, essentially.
They don't have. Well, they do it anyways via CDNs, right?
YouTube buys that CDN.
So, and YouTube's going to pay AT&T and everybody else to put a little hard drive within their data centers, or they're going to put. Yeah, but the thing is, okay, you can put CDNs as in the middle, built into a router. Say Cisco releases a new Netgear router, and it's got a 1 terabyte hard drive in it. That's the goal of this. You think that TCP IP and standard IP can really be the Internet of Things? It is impossible. If you want a true Internet of Things, this is the way to do it, where things contribute to the network, but not everything consumes. TCP today, currently, everything consumes. Your cell phone consumes data for every second. It never puts anything back into the network. Therefore, the Internet of Things is going to be a physical impossibility, because you'll never have enough towers or bandwidth to stream all that data to the Internet of Things. That's why as much as people in Washington, D.C. and elsewhere keep going about, yelling about the Internet of Things, we don't have the bandwidth to stream that much data to 300 million endpoints.
That's why IP multicast was created.
Yes, and it solves some of the problems.
I think it solves most of these problems. The biggest problem is it's turned off.
Okay.
In most places.
Fair enough. And the ISPs probably won't ever
They
turn
just
on.
turned it on, problem solved.
Yeah.
And it's turned on by default in IPv6, but
Yes.
the problem is no one's using IPv6.
Nobody's using IPv6, and well, they have the HCP problems, right? Whatever. IPv6 is.
So multicast resolves
It
the
resolves.
issue here.
So you said you asked the node above you, and then it asked nodes at nodes. What if you're specifically asking for data that you know doesn't exist?
Then it's going to make it straight to the producer.
Right, but it seems like that would be amplified throughout the network, especially if there's not a hierarchy.
Yeah,
You don't know what your
the
traffic's
hierarchy
gonna
is
go.
just like DNS.
If you ask a secondary node, and that asks all the nodes it knows, some of those nodes are going to know other nodes that are sister nodes to your secondary node, and the same question is going to be asked.
No, it's always going to move up, but only one
What does
step.
up mean if there's no?
Up to, as in DNS, the root server. Think in DNS terms, it's a root
So
server.
even in this distributed network where it's just about data and not about addresses, there's one source of authority.
You're going to be the root for your domain name. Nobody else is. If you make a request for yahoo.com, Yahoo is the root server for yahoo.com. So if you make a request for yahoo.com
Okay,
slash
so
data,
it's not.
no, there is no
I think maybe
central.
you were characterizing of it as data unrelated to its source, which needs to get
Data,
resolved to its source eventually.
sooner or later, when the initial time data gets produced, it has to come from somewhere.
But the somewhere is known from the first hop.
Yes.
You already know, first you're looking
Absolutely.
for the place,
Absolutely.
and then you're looking for the rest.
That's built in within the naming convention. You had a question? Yes, sir.
What prevents me from advertising myself as YouTube?
Knock yourself out. Please do. The problem is, I'm going to go to youtube.com and download their certificate.
How do you know you've gotten to that YouTube and not me, and I'm downloading my
Because
certificate?
you don't, well, that I have to trust somebody. Sooner or later, I'm going to have to trust the certificate.
Sounds like you've got a big opening.
Well, this is,
That-
you
that-
said there's basically a central authority.
There is a central
It's like
authority
the
that publishes.
PGP key
Yeah.
servers, right?
Same exact thing. It's PGP key
So
server.
you're basically trusting all these universities to check against each other to maintain this list of valid keys that anyone can go submit one to.
Correct.
And there's no, if they don't charge you, then there's no workforce of people to verify that you're actually the real world organization.
Except
It's whoever registers it first.
the current private network is called the NBN network, and they will not allow anybody that's not verified. But going forward, again, this is, Indian version 0.3 was released 3 weeks ago. Even though it's been working since 2010.
Going forward, we have to create an organization like ICANN or IANA to charge us money.
They are going to go through ICANN and IANA. Currently, they're talking about what. That's one of the outstanding topics.
So ICANN is one organization that most discourages the use of SSL.
I know. Again, I'll ask the people, I'll ask the universities, and I'll get back to you on that. I do not, I know that's still an outstanding question. All right, so when we request for data, suppose you ask for what you want. I want that April Fool poster thingy. UUASC.org, Steve_Rieger, because I'm the producer. UUASC is he's a producer, but I produce in lieu of him. Talks, April Fool's PDF. Or I go to Flickr.com, photo, dude, desert. Or I go to room thermostat #1 in the stats. In any one of these is data. When I make a request for this, I don't necessarily have to speak to the actual thermostat because chances are that thermostat constantly sends out data. It constantly says, I'm 72 degrees, I'm 72 degrees, I'm 72 degrees. So when I make that request, chances are I'm not going to get all the way to the thermostat. I'm going to go to one hop above it because he sent out the data already. Yes, the expiration.
Assuming somebody's listening to it already.
Well, it doesn't make it up if somebody's listening. He sends out the data to upstream, and the timeout, the expiration for it is 0.5 seconds. The data is going to exist for 0.5 seconds, or however long it takes to traverse lines. Because the data that we have on the internet today is already named, even though we don't think it is. Every single piece of data is already named. The packets aren't named, but the data is already named. We can piggyback on that, and each packet gets a subsequent number, serial number, so to speak. We kind of piggyback on a DNS system the way it is today with the naming convention because it works, right? Oh, I put this in. All right. So, all right, before we go on.
So in a
do
sense,
you understand the concept of NDN? It's out of left field. It's different, and we're going to have to go into a lot more technical details and
Multi-level CDN.
yeah.
exactly. But it's multi-level CDN without overhead, without acknowledgement, security built in. You don't need SSL anymore. You understand what I'm saying? Because once you dig into it, and we can have a lot more in-depth discussion offline, but once you start thinking about it, you can accomplish. It is a multi-level CDN, but it turns the whole internet, the internets or the interwebs, whatever you want to call it, it turns it into a CDN for everything.
You could do that now if you were a dick. Like you could create DNS entries that were text, 255 character, and like chunk data up into those, and then make all these ridiculous DNS requests, and that would all get propagated out, and you could do like.
But who's going to read it?
Well,
nobody.
Well, anyone that, if you had your own client of some sort that understood how to read these chunks, put all that together, you could.
SPF, there's other HINFO records. All those records are just about that, storing data in the DNS system, which means it'll get cached through multi-hop.
So you can do like a really shitty version of it today.
Yeah. Yes, sir. You have a question?
What if you have data that's intended for one and only one consumer?
But then you signed that with a separate certificate.
And how do I make him the only one who knows what that certificate is?
Because nobody else is going to know the naming scheme of that data. Nobody knows what you name your data unless you advertise it, which you're not going to do.
You mean like a secret URL?
Yeah, same concept, same concept. But the difference is that you can guess a secret URL and read whatever's there. Even if you guess the secret name to this data, you can't read it because he signed and encrypted. Right?
With your key. So all the clients.
He's the producer. He signs and encrypts it.
So all the clients have a public and private key as well.
Everybody has a public and a private key. Correct. Everybody has a public and a private key. Yes, sir.
What if I want to change the temperature on the thermostat? Is that sending data to it, or is that so it's set the thermostat 3 hops away, and I want to change the temperature.
I don't think we've gotten that far.
Okay.
No, I'll be honest. I don't think we've gotten that far with it.
Well,
it's still just post and gets, right?
It's just right now.
No, it's.
I know there's a way to do it, but I haven't done that. UCLA actually has 3 buildings on campus that are controlled and run by NDN network.
Wow.
By the NDN protocol.
It would have to be polling.
It's constantly polling, but they actually had a test mode where they ran a whole kind of like a NASA control center, and they had 12 people on campus running around with Google Glass that were converted to run over NDN. And it was an amazing experiment. They have videos of it. I can look it up and send it out to you.
It's actually a lot less efficient than having it be.
So the way you would solve the NDN, the managing the thermostat over NDN, is you just have two different streams, right? You'd have the manager agent would express the interest of, I want to know what the temperature reading is on this thermostat in, in the break room. The thermostat in the break room says, I want to know
If
I'm interested in getting any commands from the agent that manages me.
In other words, it sends out invites as well.
No, there's just, it would just be two
Everybody
different
only
streams.
Everybody says, I want to read data. I want to read data. I
Right.
wanna read data.
And they're both wanting to read data from each other.
Data never moves across the network unless it's been requested by someone.
Now, I want to ask you a question. Sir. Has anybody done some fun with the name Indian and started talking with the Papagoes and the Apache as various subsystems?
It's named data networking. I call it NDN, but it's really named data networking.
Yeah.
Is there, well, I'll put it, here's another, is there a big Indian and a little Indian?
Well, you'll have to ask the locals. All right, so why is security difficult today? And then we'll compare it a little bit in the end. And we'll try to touch on a bunch of separate items, and at the end, I'll kind of try to tie it together so you guys can see this in action, how it works and all that.
Yes.
The trust the user gets in the content that they depend on is tied inextricably to the connection over which it was treated. That trust is transient, leaving no reliable traces on the content after the connection ends. Securing my IP means I have to secure my perimeter. If people punch holes, I mentioned that to you a little while ago, if people punch holes in the barrier to get work done, chances are you're going to open a hole, so it's easier for somebody to get in, but you can't completely lock it down because we'll never get any work. So you have to open holes today. The ultimate question from application, did I get the right data I need? That's what Oracle wants to know. When you run Oracle Rack or SAP or you're streaming in NFL or YouTube, whatever it is, did I get the right data I need? TCP packets are somewhat sequential and you know where you stand and restarts, and drops and all that. And in order to speak into my data, it's secrecy, secrecy is required because somebody put a sniffer in line or Wireshark and look at all my packets.
Great firewall of China.
Yeah. NDN secures data directly. Every data packet is signed by your producer. It reduces the reliance on trusting network intermediaries. We don't trust anybody in the middle because YouTube.com signed every packet of data that they produce. Every video packet, every packet for every video, or whatever you want. NFL or YouTube.
How's it hard to spoof YouTube's?
Today, you can spoof YouTube's key because they are the producer of the data. And I trust them, and I got my key either from them or from somebody I trust. Somebody's always going to be able to convince you that he or she is who they are not. The question is, at some point, you have to do a handshake with one entity that you absolutely trust. And I don't think there's a way to get around that.
And in the current model, that's your web browser, which comes packaged with a bunch of CAs.
Yes. Yes. Correct. Okay, yeah. Even still gets people man in the middle, but
What's
the DNS
CA?
That's the SSL.
Leaves one problem to solve all of that. We have to verify the data indeed is signed by the producer's key. And each NDN application has its trust model to verify the producer's key. So if you write an NDN application, remember, NDN is a protocol. If you write an application that will run on this protocol, you get to choose how to verify. It can go back to Google or YouTube.com headquarters and retrieve the key every 24 hours or every 5 minutes, or it can just download it the first time from the closest location wherever the key is located and trust it implicitly. That is left up to the application developer. The protocol, we don't care.
So you can't feel like an inherent sense of trust. Well, it's SSL, so I know it's safe because there's certain standards that come with that. Every different application, they're all encrypted, but to different levels of security. based on what some application developer chose.
But why should I? But that's the whole point of a protocol. A protocol shouldn't be enforcing how to do stuff.
Unless it's a
At that
security
point.
protocol.
Which it really isn't. So SSL kind of is, but this is not. All right, and so routing. This is not routing. This is not routing. This is okay. So I have two. Okay, I have two applications. I don't know why that slide said routing. This is not routing. This is two applications that are currently up that you can actually download and run. Or actually, this one you can download and run. The second one, I don't know if it's publicly available. I played with it, but I don't know if it's publicly available. ChronoChat is a chat, is IM. What we know as IM for multiple users running over the NDN network. So you'll have to install NDN and NFD in order to get this. But once you have NDN and NFD running, you can install ChronoChat, and it's a chat application that will utilize most likely UDP if you allow it. Whatever port, I'll look up which port it is, but you can specify a port. But when you send out a chat message, it doesn't. You don't do a separate stream to everybody. If everybody is downstream from you, it does a single stream out to the first hop, and then if it needs to get split, it gets split, and so on and so forth. It's like we saw that tree, how it works. But if you want to test NDN in your private work environment, you want to have a secure chat line, that's the way to do it, because it doesn't run over TCP. Nobody can snip. I mean, chances are, if you put on encryption, nobody's going to be able to decrypt your packets, even if they can snip. And that's available to you to run today, open source.
But you're sending it to more people, potentially.
It's up to you.
Well, I mean,
it's just
the
like,
nature of the protocol, it sounds like you're not routing, so.
Again, we don't send data. We produce data. Whoever wants to see it gets to see it. So whoever's going to be in my chat room is going to retrieve the data. If they're not in my chat room, they're never going to make a request for the data that was given to the chat room, right?
So they have to just continuously pull. There's no other alternative to chat.
The protocol polls for you. Yes, but again, we're not. It's hard to. We're doing away with the whole concept of sending data and we're switching it to only retrieve.
Except that it still runs on IP.
For now, it's up to you. You don't have to run this over IP.
Oh, okay.
You can run this over whatever addressing scheme you want. You want to run it over, say, UDP with NFD, feel free to do so.
UDP is on top of IP.
That is true. But you're not going to get, okay, past me, you're going to get an IP.
Ethernet frames.
Yeah,
You should, yeah, you can.
you just get a job at UCLA and you could just
You could.
plug right in. You get the .edu address and boom, you're in.
You're set. But if here, honestly, if anybody here is in a university and you want to play around with it, knock yourself up. Even if you're not in a university, they will let you into the UCLA or whatever, the worldwide university test bed. They just won't give you official certificate. They will not issue an NDN certificate. They will issue a guest certificate. So if you produce data, everybody will read it as a guest. And it's going to say that a guest produced this data, not an actual NDN member.
Is there an SSH app yet?
There's a chat app.
There's
so
a chat app.
You're getting.
There's a Java client for NDN, so it should be really easy to write an SSH app. But
Oh, and the data is encrypted already. So Telnet, is there a Telnet app?
I don't know. I can ask.
Well, no, because the first the first internet connection on the IMS that came out of UCLA. Yeah.
Let me say something about UCLA. I think everybody in here is aware of it, but I don't know. There's a Linux user group at UCLA. They've got their own hangout room, and everybody is welcome to join. So if you need a UCLA connection, just get on members. What is it? Members.ucla something? No, members.linux at UCLA. It's you get a linux.ucla.edu address. Yeah, it's very easy. Everybody here is perfectly welcome, and it gives you a connection to UCLA if you want it.
I should have. Pardon me for not extending an invitation to our Linux users on campus at UCLA.
There you are.
All right, so if you want to mimic Google Drive and Dropbox and all that without the actual Google or Dropbox server, you install the synchronization application on every NDN endpoint, say your cell phone, your laptop, your desktop, and your server, and then you share folders with that. You assign folders with the proper NDN data name, and they will always remain in sync. It's pretty much the same thing as Dropbox, except there's no Dropbox server in the middle. And every time you power up your laptop, it'll go out there and it'll resync itself with the 3 other folders that are properly shared with itself that are on the network.
So everyone keeps a copy of everything.
Yep.
So if everyone is potentially a producer, does that mean that routing tables would get dramatically larger?
We don't care how large our routing tables get.
Would the routers be, I mean, could it not be a problem?
Because I only care about a single hop.
But you're caching stuff.
I'm caching stuff, but
And if you're not caching enough, you're going to be passing a ton of stuff through. It's actually going to be a bigger burden on you than if you were caching stuff.
They ran some math on it, and I can, if you want me to, I can send you the numbers. They ran into something like 200
So
million.
they ran into this with ATM. ATM
Yep.
was supposed to make it really painless for the end users, but it made it where all the nodes in between had to basically be running the equivalent of BGP4. They all had to run PNNI, which was a huge burden. They all had to have
They did run some. The NDN people did run some tests on it. The numbers were astronomically large because the information that we cached is so small. It's a lot of data, but it's tiny bits. So it didn't have that much of an impact. The numbers are, and I can get the numbers for you if you want. For the technical stuff, I'm probably going to come back in 2 or 3 months. And do
You're doing great.
But I'm just trying to give you guys an overview. So the lessons from the application that I kind of give you for 30-second overview is on the IP challenge, the limit application semantic represented in network architecture. But here we express application semantics and network naming down to the packet level, meaning every packet is an individual name. And because of that, if you produce it once, the parent name of it is going to be /video name.mp4, then it's going to be packet 1, packet 2, packet 3. So if I request video.mp4, I'm going to get all the packets that belong to that name, and you can name it however you want past that. If you want to video, packet 1, version 1, if you update the version, but if you can only update packet number 4 with version 2, you don't have to update the whole video. This matters when it comes to making films and editing. Which is what UCLA Film School is currently doing. They're doing a live shoot of a movie, and the video editor goes in and he updates a single frame. He does not have to re-render the whole thing because the data itself resides in NDN, and he replaced a single packet.
Whoa.
Yes, don't go there, but I'm not going to go into that. But that's what UCLA Film School is currently testing. They're applying NDN to that aspect. So,
He can't just replace. He needs more than the ability to replace a single packet.
well, he replaced a single frame. He replaced a single frame.
But he needs, if he's doing an edit, a video edit, he needs to be able to replace a single frame with multiple frames, and needs to be able to replace multiple frames with a single frame, or no frames for that matter.
That I don't know. I've seen the video of how it was done, and I read the white paper, and I'm dumbing it down because I don't understand the video editing. I am not in the movie industry. I try to stay as far away from that as possible.
You've seen a strip of film.
Yes.
You've seen how every single one of those is a static photo.
Yeah.
So
Not a single frame, but he replaces packets for specific frames that he edited.
Frame, it's equivalent.
Yeah. But he only replaces the frames that he edited, but he doesn't replace the packets that were not edited.
Right.
Does that make sense?
Yeah, because a new.
So if they filmed the guy with the hand like this, and they move the hand up here, all he's replacing is this packet with whatever's in the background and this packet with the hand.
He needs to be able to not only replace this packet, he needs to be able to put in a packet that gets it there.
And he does that, but NDN allows him to not have to replace the rest of the packets.
Well, I can believe that.
That's
that one-to-one is not sufficient.
Yeah, but that's what I mean.
Many to zero has to be doable too.
And the edited out data will just age out at some point.
Yeah.
Yeah, that's.
So currently in progress, we have NDN video, which is actually live already. Chrono chat, NDN RTC. I don't know if that one's live or Chrono share.
What is RTC?
I don't know.
Real-time clock? No.
No, it's compression. It's real-time compression, but I don't think that one is live yet. I know they're working on it.
Okay, and then file sharing?
The video, the chat, and the sharing are live. You can download them from GitHub and compile them from your Linux, Mac boxes, whatever, and they will work. Again, the prerequisite to all of this is NDN and NFT. You have to have those two running in order to run this. Yes, sir.
So say an NDN packet is 1 megabyte, because that can be large, right? Are the routers then treating those as chunks but then splitting it up into small, multiple IP packets?
The router just forwards a single megabit packet.
But it's got to be chunked up into, I mean, that's no larger than an MTU.
That's why when you're running over TCP, you have to run on 1500.
So is the routers, various NDN routers responsible for splitting those up and recombining them?
The first TCP router is going to split it, and it's going to do the TCP overlay on top of it, right?
So if that packet goes from NDN router to NDN router, is each router recombining that into a chunk and then splitting it as it passes it on, or is it? Okay.
Yeah, each hop is reassemble it, break it apart.
Stream, and then you transport.
It'd be slower if they've all got to reassemble them, but maybe there's stream for multiple routers.
Does it have to capture the entire file before it can get the benefit like a CDN? So it can't store them. It has to store them forward, but it can't do it.
He's saying what the producer produces cannot necessarily send it as a singles transmission.
So wouldn't that add a ton of
My
latency?
biggest thing is, well, my biggest thing is, why would you run NDN over TCP and not over UDP? Because you just make, you just.
I keep MTUs like 15.
Well, a lot of networks are not UDP friendly.
Yeah, that's true.
Or
But
NDN.
this one is. Or
Maybe
my
UCLA
home.
is, yeah.
No, my home network where I'm running a bunch of NDN nodes is, I'm running it only over UDP.
Right. UDP
So that
usually
was-
goes out just fine. It's getting it back in.
But again, I don't want anything back in.
No, you probably want the data you have.
No,
back.
but I've never had a problem receiving the data.
No. But some routers are friendly, some routers hate UDP.
All right, so building automation and management is in the works. At UCLA, they have, I think, 3 buildings that are actually running NDN to control HVAC, lights, facilities, and all that stuff. It's pretty nice. There is some amazing white papers out there on all of that, on how to actually implement this stuff. There's tons of drivers for various smart and non-smart devices out there. Vehicular net is being proposed.
Interesting.
It's the automatic cars have to communicate with each other. TCP is never going to really be efficient in that case, and UDP is better, but UDP has problems, so they're proposing NDN for autonomous cars as we know them, believe it or not. NDN CCL doesn't really exist. NDN CXX is what is the libraries for NDN. That's what when I keep mentioning NDN, the software is called NDN CXX.
What's it being developed on mostly?
What's that?
What's it being developed on mostly?
C++. There's Python, Node.js. ChronoSync is if you want to sync up for chat purposes or Google Drive disks. Repo is a repository, is a remote repository, meaning if you want to kind of, it's Git in the cloud without actual hard drives in the middle. I'm not going to get into it now. There's enough reading you can do about that online. NDN forwarding, this is how you get from NDN to another NDN device or to a non-NDN device. Or however you want to do. If you want to forward from self to anything, you have to get NFT in the mix. That's your router. That's what forwards packets.
So people right now that want to play with this are going to run one of those at home.
They're going to run NDN CX. You're going to install NDN CXX and an NFT.
They'll have an NFT at home.
Yes. Oh, absolutely. Absolutely.
And then that'll be talking to an NFT at UCLA or something.
Yeah, correct. And then it does the reverse.
So right now, it's like all the content you would get through the current test network and it might never hit more than 2 hops.
I'll show you a map. We have a live map. We kind of went through all this already. Not in. We won't go through this. You go through the
And you're going to have post a link
Yeah, I
to
sent
the
you
slides,
actually the link
okay,
for all this.
on an old-fashioned TCP
Yeah.
IP network.
We went through this, and I know it's going to happen out of order. This shows you how NDN actually does routing of packets. We discussed it, but I'd rather get to the GUI bits. Enough presentation stuff. All right, so we did a couple of evaluations. This is TCP, and this is NDN, and that's the pipe. I'll let you read it. I'll let you look at it. So a content-centric network ran 22% better than TCP.
Running NDN over UDP.
Running NDN over UDP, correct. And again, NDN over UDP, which is at 5%. NDN over Ethernet, which is TCP, has a bigger overhead.
Of course, that's on a clean network that it doesn't have any errors to have to correct for or anything.
There is no error correction in NDN.
So it would have to request the entire data all over again.
But the entire data was one hop up. That's the genius. I don't have to go back to youtube.com to get the packet. I go one hop up.
And that hop will go up to youtube.com to get the packet.
That one hop will go one hop up. The chances are, again, the more people that use the network, the better it gets.
It's like BitTorrent. The more popular it is,
Exactly.
the easier and more reliable you can download it.
Pretty much. Yeah.
The Netflix would be great for this.
Netflix would be amazing.
If you like popular videos.
Yes,
If you're one of those weirdos that likes
it.
independent film,
Yeah.
you're gonna have a hard time
Like
finding.
me, I
your
like the
BitTorrent
bicycle thief, and of course, I'm so I likes it. But you can see the numbers are really good, and it's. We have one more, and here's the thing. If you do it like you said, if you like independent films, NDN is going to be much worse than TCP. But if you go to popular data, NDN is much better than TCP. That's just, I mean, that's where.
Life in the big city.
Yep. So if you live in Minnesota, just stick with that. This is how long it took. Again, just some more IP versus NDN.
This is like war on the CDNs. The big CDN companies can't be happy about this.
This is the first public presentation in the world done about NDN. I shit you not. Flat out.
So we got a little while before the CDNs try to kill you.
Yes, we're not.
Hey,
Yes.
I work for a CDN. Your days are numbered.
Tell your
I'm
CDN.
deleting this. Huh?
Remember, you started this with Cisco as sponsor.
Cisco actually dumped a ton of money in this late last year.
Well, Cisco's a networking company. They're not a CDN.
No, they're not a CDN.
Oh,
But say that
their
if
devices
a
are gonna have
CDN,
I'm
if
gonna
a
kill Cisco
CDN is
too.
smart, they would adopt this technology for back-end propagation. Don't you think?
Well, yeah, there's a lot of different uses.
Yeah, I'm sure.
Aside from just, if you want to broadcast, you may want to broadcast information out all over the world, but like you said, you may want to broadcast a lot of information just within the building, right?
This would be perfect.
In a lab.
If you want to run a private network with a lot of data from a lot of points to a lot of points that's secure, I think this is a perfect candidate. Back-end CDN, Oracle rack servers. That's where I see it making a massive difference. What's that? Yep. Or anything along those lines. Or in a hospital.
Yeah, all the MRI images and
all of that data that doctors need ASAP. We only fetch the packet once. We only fetch the data once. And I don't have to go back to Corona Data Center if I work for Kaiser. I don't have to go back to Corona Data Center to get the damn MRI.
It's like installing Squid.
What?
It's like installing Squid.
Pretty much.
and
Except all of that we're talking is built into the actual protocol.
and the doctor and the resident and the nurses and other consulting doctors, right? I can watch that big image with one copy.
All right, this is just some slides I stole, but I'm going to go through them. Well, TCP in the early 80s was promising new technology, largely unknown outside the small community. Federal funding led TCP to its success, yada, 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 all that good stuff. A number of problems were exposed and resolved. We all know, whoever's in this room sure knows this stuff. DNS development, congestion, evolution of the routing system, other stuff out there. The road to the new architecture is application-driven development. We don't care what you produce or how you produce it. You control your data. You control how big packets are, whether it gets signed or not, and who's allowed to see it. So again, if Netflix wants to, yes, people are going to be able to share the key for Netflix amongst each other if you don't have an account. People do that anyways, right?
I don't know if that'll make Netflix happy.
Again, but people do that anyways. How many people do we know that share Netflix accounts? Or HBO Go accounts? It's data is out there, the logins. Access to the data is out there. But we give the producers more control over data.
And also they'll figure out schemes.
Yeah. There's always
It's,
going to be
Right, if the data comes directly from the producer, that gives the producer more control of the data.
well,
If
all
the data
the
gets cached with
producer
multiple
has,
layers going down.
but all the producer has to do is release packet version 2, which will supersede version 1 because it gets advertised.
That I can steal this original, since it has to be decoded for me to see it.
Yeah, so you're going to store it on your local hard drive, and you're not going to be able to send it anywhere on the network because version 2 is on the network.
No, I just advertise it as something else.
Fair enough. Then you can do that today.
Yeah.
So we're not
It doesn't
introducing
have as much
something
control
worse.
as you were trying to make it sound.
No, my point is we're not making anything worse. We're not fixing the possibility of theft of data, but we're not making it worse when it comes to the streaming.
But since we're caching it, we do run into a problem of regulatory problems in other countries like Germany, where they'll nail you for running a Tor output node.
But if you don't want to cache, you don't have to cache. You can set your NFD. You go through the NFD.com file in your server or whatever it is, and you can set, do you want to cache? Do you don't want to cache? How long do you want to cache? How much do you want to cache?
Can you say what you're going to cache and what you're?
You can say you only want to cache from specific prefixes. Yes, absolutely. You have absolute granular control.
Just
You
like a
only
firewall.
want what?
It's like a firewall.
For all intents and purposes. If you only want to cache
Kind
from
of like
producers,
perimeter-based security. Like
yes.
a firewall.
If you want to do that, yeah. If you only want to cache from people that you have as a trusted certificate from, you can do that as well.
Of course, you talk to the UCLA networking people, and they'll tell you about how when they did some things in their firewall to kill BitTorrent, it like cut their network traffic down 90%. So you can bet that the big providers are going to be the first ones to introduce perimeter level security.
Oh, I'm sure. Sooner or later they will.
The big shots are gonna co-opt the whole thing.
That's what they usually do. That's why we don't have multicast.
Again, I am not a networking guru, so.
No, I'm sorry.
No, it's fine. It's fine. I
I
understand what you're talking about.
I know nothing about this. You've introduced us a lot to this. Thank you.
So we're gonna. That's my goal. Is I'm not a networking guy, so I'm going to. All right. So now let's. What we're gonna do is we're gonna. Why is it so wacky? All right. So I'm gonna bring this up. My IP address is 100.43.25. This only I can. This is a map of the current live NDN network around the globe. Yeah, we were too zoom out. So let me go zoom in here.
Does it tell us how many total nodes there
are? There's not much. Yeah, 1 second. Yes, we will see how many nodes there are.
Wow. It's so busy.
It's about 3 in the state.
No, there's 4 in the state of California. That is, which island do we have out there?
Catalina.
Yes, that's Catalina Island.
Oh, it's a little south. I think we put that in Mexico.
That's in Mexico?
That's actually where Guadalupe Island is.
Okay, whatever island it is. I thought it was Catalina.
Near San Luis.
Yeah. The scale of the map is a little off.
Yeah,
that's okay.
The scale of the map.
I get it.
But this is a live actual network.
No, and actually look.
There's University of Arizona.
Yeah, but look, from the distance from UCLA to Catalina is like half or almost a third of the distance to Arizona.
Give
That's
a break. It's not the scale.
Yeah, it's not. I think that's Catalina. Hold on.
Well, that is south of the Mexican border visually on the
I'm
map.
trying to see if they advertise who they are. No, they're not advertising who they are. So this is a map, and all these links are within that folder I sent him to distribute for everybody for the meetup. All of these links that I'm going to show you are there. So my IP address is 100.something. Let's see if I'm still here. This is browsing the NFD, which is the routing level
that's
of the NDN network. We're browsing it via web browser, standard web. This is TCP, IP, standard DNS, and all that good stuff. The HTTP, right? It is, but this is what UCLA's NDN node knows about. This is all the incoming, outgoing, and all of that. So we have all of these interfaces, and IM.100.something. It should be all the way. That's me. So that's us.
You are here.
So we are there. I just want to make sure. No, I'm 43.25. See? Oh, that is me. Okay, so I just saw the 20. So that's me. So I'm connected to the NDN network over TCP version 4. That PIP, that port. I'm connected to UCLA, which resides in that. I'm non-local. I'm on the man point never all that extra jazz. However, if we go and I'm running NDN locally, here we go. This is my local NDN. See 127.0.0.1.80.80. That's my NFD server is running on local machine on the laptop port 8080. I have absolutely no connections outside the TCP. Actually, I do have one over there. No, I don't. I don't have any connections outside the TCP because I'm running two daemons, one for this and one to browse the web. I separated them so I can show you the small, tiny network. So I am not connected on TCP. I'm pretty much listening, but I haven't really connected to anything. But now you can see I'm not connected to anything. I'm running the NDN protocol, but I have 1, 2, 3, 4, 5, 6, 2 of which are UDP and TCP. But now you see the socket, and that's the NDN internal.
So what does WS stand for?
I don't know what it stands for,
But it means it's
internal NDN.
internal NDN. Okay.
So that's how many connections. I don't care how you connect to me. I don't care. I never will. All I do is I have data. If you want it, I will give it to you. The NFD, utility program, library, whatever you want to call it, is going to do the translation. And he's going to take the data and send it where it needs to go. And he's going to take requests and send it to NDN, which is going to then send the data that was produced at an earlier date. Localhost, start time, current time, all 4 hours. A name tree entry.
You were talking about web browsing through.
Yep, we'll get to that in a moment. We'll get to that in a moment. These are all my faces I have. These are all the non-locals, but they're really locals. That's a MAC address. This is what it looks like. You bring up NDN or NFD on the NDN network. Forward, reverse spaces, strategies. You can have different strategies. This is kind of like what we know as kind of is routing, is what we call a strategy in NDN. If I were to do a slash, and I'll go back to, again, this is my local, right? So if I were to go back to all the way to the bottom and look at UCLA strategies. If I want to do broadcast, I can use this route, broadcast or best route. I can put in different strategies for different domain names, but a domain name here, sorry I'm all over the place. Kind of hard to, it took me a while to get my head around this.
So the NFTs have their own routing protocol to know which other NFT to contact.
Yes.
Send the request.
That's if you that's what a strategy is for. You say this is my preferred method of communication.
Like setting a metric on a routing.
But it's unlimited as to how many you can have. It's up to you. Or you can just do a
It'll
broadcast.
Propagate this to the next one down.
Yeah. Or you can do a broadcast, which means communicate with everybody. But if you want to make a tunnel, you tell NFD only my strategy for any packet that comes out of /UCLA/NDN.
You want it to go through.
I want it to go through the strategy.
Right.
Yeah.
So just looking at this is interesting. This.
Also, yeah. You see how all of these are NDN/EDU/University of Michigan.
Yeah, UCI's up top.
Yeah, UCI is up there. NDN orange. Some other university, EDU, I don't know which.
That's
St. Louis.
St. Louis wasn't. Yeah.
But you see how all of these have interfaces. Localhost,
Connections with other.
Illinois, France. There's Japan. There's China.
And the cost is how quickly that interface will get to that.
So every NFT knows about Every other entity?
In this case, yes, because I told him.
It doesn't have to be that way.
It doesn't have to
You
be
could
that.
just know about one neighbor and that'd be enough.
If I ever spoke to UCLA, which we did, which we did because that's my IP address. So my iFace is 3125, right? So let's see how many other people know about 3125. In the end, UCLA, he has interface with face 3125, which is me.
So I mean, he knows about you or he's talking?
He knows about him.
Because he's talking to you.
Yeah, because I'm speaking to him right now, and I'll show you how we're browsing the web. But he knows about us. EDU UCLA Remap Ping knows about us, and NDN Broadcast knows about us. NDN Broadcast is housed within UCLA.
But without an SPF protocol, how can it know what the best route's going to be? You have to manually tell it.
I don't know.
BGP style is SPF.
That I don't know. That's above my head. If you send me the question, I will definitely answer. But again, EDU UCLA Remap knows about me, NDN Broadcast knows about me, UCLA Remap, and that's it. So even though we have all of these other people on this network, none of them know about me because I've never spoken to them. That makes sense?
Oh, Face ID is the same.
I mean, how are we?
Face ID is, so Face ID is of course.
Oh, Face ID is concurrent, pretty much. You come in, you get a number.
They're unique to your node.
As long as you remain active, that's going to remain yours. There's a timeout period, and then he came, whoever this is, I guess they restarted the local socket. He came immediately after me. But come back tomorrow, there might be up to either 3,500, or it might, if they start over at 0, he might give 3125 to somebody else.
Only unique within a given
Within a given NFD, depending on the TTLs that you set up within that NFD. So you can say your TTL is really short, or you can send very long.
Is it safe to say that everyone that's testing this is using UCLA, so therefore there are probably 3,000 NFTs running?
Everybody that's on this map is in the NDN network.
It doesn't look like there's 3,000.
No.
It looks like there's 30.
No, there's not 3,000 now. But at one point, if somebody gave a ping to UCLA,
It's a new number.
they got a number. And then somebody came in after them and got a different number, but that whoever was between 79 and 18, they all expired.
So what happens when we run out of numbers?
You start over again. Yeah,
What's the
I
expired?
don't know if there's actual limit to this number. I'm sure somebody run the test. If not, I can run it for you. But does this all make sense to you? All right, so the only kind of web browsing we can really do on the actual NDN network is this.
So you could set up another client machine that did not run an NFD because it was talking through your computer that already was running NFD.
Correct.
Whether it wanted to
The
use
only
Unix sockets or
question is
TCP.
how are these two computers going to talk to each other? The only way they can talk is through socket.
Right.
Anything beyond socket, you need an
So you could run an NDN client program that knew how to use that socket to talk to your NFD. So there could be a lot more than that many machines running the NDN software.
But that's
just how
more
many
than
NFDs.
Yes, correct.
Because all of UCLA could run one if they wanted to, and everyone can talk to it with the socket.
If they so desire, yes. So here we're browsing. This is the only NDN publicly available website that I know of. It's not HTTP. It is actually NDN protocol. And it's,
Wow.
but this is, yeah. So all NDN tech reports are available.
They put the exciting stuff here.
Yes, they put all of the white papers here.
I was thinking girls in bikinis, but not happening.
Not yet.
TPS.
I can put the request into that.
It does.
Yeah,
Flashback there.
where are the cat videos?
I don't know. This is all NDN related.
Could you express some interest in cat videos and see what we get?
Sure.
Where does your browser know what to do with NDN?
Because I hijacked the browser's connection for that window.
So the producers don't have any kind of analytics. They don't know who's browsing their stuff. I think a lot of people that enjoy analytics are not going to.
So I have four 1-minute videos that show you some technical stuff.
Speaking of analytics, like we keep thinking like NDN's going to replace everything. It's like
No.
It's not, right? It's like just there, and so like there's probably plenty of pages you bring up over TCP, and just like the graphical assets might come over NDN, or just the video might come over NDN, but like we don't have to think about it as either or.
I just put the NDN as a TCP replacement just so that you would come into.
No, NDN
Steve.
can replace TCP. It doesn't have to. It can work in conjunction with TCP. Again, what I would love to see this for is Oracle RAC. Any back-end communication that needs low latency, high throughput, and lots of data, NDN makes perfect example. I think that's where it belongs. Or in very enclosed and restricted environments, such as a hospital setting, or
like at a multi-room conference.
Yes.
You could watch stuff in other rooms, videos in other rooms.
If there's a lot of devices in a small controlled environment, NDN
scale 14. You know,
there is an iPhone and an Android app, libraries I should, not an app. There are libraries for iPhone and Android that you can write your own apps on. So if you want to, you can do that.
But there's a video streaming app.
There is a video streaming app, but not for the cell phones. There's one for desktops.
How's it work?
Works good, as long as you produce the data.
Can things like OpenWrt or any of the open source embedded networking distributions support NDN? For example, let's say scale, right? You're going to have 3,500 geeks in a hotel or wherever they're going to have it next year. And they're going to have different devices, and you're going to have 8 different tracks and maybe other things where people want to stream content. And they're going to have a bunch. They're going to have. I think they have like.
Question is, I ported NDN to the Linksys boxes that run DDWRT.
Cool. So
you can rip out TCP from that completely,
or dual stack and whatever.
Or dual stack. Yes.
So they can, because I think they use Netgear routers. They use Netgear routers.
But you can run, if you install NDN and NFV on a Netgear router, or whatever router you want, really.
Yeah.
You're running an NDN router.
But it's a daemon that lives in user space, right?
What's that?
It's a daemon that lives in user space, no kernel mods, right?
No, there's the kernel mod for it.
Of course, there's a kernel
mod. It's not easy. You have to build the kernel on a desktop and then copy it.
Well, for WRT.
Yeah, for DDWRT, yeah.
But I mean, this project always requires a kernel mod?
No.
Oh, it can't just run as a user space daemon?
Yes, absolutely. Yeah. That's on my laptop. That's what I'm running it as. But just real quick. On the command line, NDN sec is going to give you all the information about NDN. There's no NDN, is just a protocol, so you start it. If you want to interact with it, you do NDN sec. /etsy/ndn.conf is your config file. I'm not going to go into it. It's convoluted and you have a lot of, the strategy choices you can have in ndn.conf are immense. So read it. If you have any questions, I'm on UUASC. If I did NDN sec list, I listed the keys that I'm running. Steve Rieger, I have an asterisk there marking that's me. However, I imported Luca, however he pronounces his last name, from Orange University on the NDN network. And you see, I can forge myself, I can create my own certificate and name it /ndn/edu/UCLA, but nobody's going to accept that certificate. So what's the use for it? So if I advertise myself as Steve Rieger, they know me from the mailing list, from Redmine, from all that other stuff, and they trust me. And I'm hoping that one day they'll allow me in. Whatever, I don't care. I just enjoy this. This is amazing technology. These are all the commands that you can get, that you can work with on the NDN, NDN sec. There's not much to show. Oh, yes. I'm just going to show you. I have 4 1-minute videos. Do we have time?
Yeah, we do. Go.
No, there's no audio there. I'm just going to demonstrate.
Slideshow on cruise control.
Yeah, pretty much. Good morning. I need to add some comments.
You are the audio.
No,
Just
no,
keep
but here you're
talking.
gonna see how it actually runs in real life. When this node fails, the stream never gets interrupted, ever.
Who,
You show stuff to a Unix group on Macintosh.
no, that's Unix.
Yeah.
Well, it is.
So it's
VST on the
VST4.
So we can see how
Sharing with-
it just kind of fails over without having to issue the major commands. Distributor publication, yeah. That's interesting. Again, all of these are literally 1-minute videos.
My attention span's not that long from streaming into
Yeah.
Yeah.
I've heard of mine though, maybe 1 to 6 seconds. That's it? Yeah.
6-second videos, yeah, like this is too long.
Maybe.
Yawn.
No, we'll add some.
So to be effective, we need people to set up these cache nodes in the middle of the network.
You know, if there's no cache nodes, it'll get cached to the person that requests
Since it's just the publisher runs it and you run it, then the whole CDN benefit is lost. It's because you get that already. Your browser caches things, and on the publisher side, it becomes
the whole point. Hopefully, people use this. Your browser will cache it. Your disk will cache it. The router in the middle will cache
That's the
it.
thing, but they're not going to get the tier 1 providers in the middle to cache.
So if you consider advantage.
Plus, they have to go through their network.
It would be somewhat that are.
As long as they're distinct from the CDN providers that will hate this.
But there's a lot of
The
people that are,
Verizons of the
there's a
world.
lot of enterprises that are going to hate this. We also are going to like this.
Who's gonna hate it?
CDNs.
Akamai,
Yeah,
Verizon.
Akamai's going to hate this. All the statistics companies are going to hate this. They can't see anything.
But again, you don't have to do everything over NDN. You can do most everything else over HTTP and just do some stuff over NDN. It's not like you're creating.
You don't have to.
Yeah. So I mean,
The way a lot of people use CDNs now.
Some stuff
Right.
you're gonna want to do.
Just as the assets.
They ain't gonna hate it, they're just gonna co-opt it.
It's open source, so.
Well, they co-opted multicast real easy. They just turned it off.
Networking is in response suite, so I'm learning a ton just by learning this. I've been involved with this for 6 months now, and I'm still learning everything.
Well, it sounds like you know what you're talking about.
Somewhat.
We got it running.
Yeah, no, I got
That's-
it running. It's not that hard. I mean, I wrote a bunch of Docker. I actually got it running in Odroid. Arduino, I got it running. I ported it to Arduino and to Odroid.
Wasn't too much of a memory hog.
No. The simulator, you can actually simulate a massive grid. There's something called a neon sim.
Spikes, VMs to.
No, just it creates tiny little nodes within its own space that takes up a little bit of
Like
memory.
fake NFTs.
But you can set up 1 million, and it's amazing because then you bring up the NFT status page.
You build your own internet.
Yeah, pretty much. But that's how I test stuff. So you can exclude, what this video shows is how you can say, I want these packets, but specifically not a specific. Well, that kind of is the end of my whole spiel here. It did go, well, I hope you guys enjoyed it.
Yeah.
Oh, yeah, thank you. So we'll have you back. Oh, you finished right at 9 o'clock. Awesome.
Yeah. I'd like to do a deeper dive in a couple of months.
Oh, definitely, yeah. Oh, yeah, so thank you, Steve, for a very interesting, very novel presentation. And who knows, maybe it is the first named data networking. So, hey, remember when you're talking with your grandkids or whatever about named data networking?
I was there.
Yeah, you heard it here first at UUASC, UUASC.org. All up, he said he sent me some links.
Yeah.
I will email those out to the mailing list you can find at UUASC.org. And I'll also post it up in the comments section of the UUASC site on meetup.com as well. and I'll put it in the YouTube page. There is, this is live stream via Google Hangouts on Air to YouTube. You search for UUASC-LA, you can find all of our previous presentations that didn't bomb out. And at some point, I will take it down and re-edit it and post it back up with the same title, just to cut out the half an hour of chit-chat before the presentation someday. Well, I'm on vacation for a couple days next week, so who knows?
You said it's at UUASC-LA.
Okay. If you're at YouTube, search for UUASC-LA, and you will find some cat videos and some UUASC presentations. Okay, so next month we'll probably meet here. I'm sure Kathy. Huh? Carol, I'm just a couple of days. Oh, that's right. So we'll meet next month, sometime in May. We'll someday in May we'll probably meet here for Ned Lerner's chef presentation. And then if you're interested in speaking, let me know. And hey, we're going to head over to the restaurant that's not too noisy.
One more thing that this is very much in development. This is still very much in development. It's not a finished product. It's probably going to be another 2 years.
Well,
We're only on version 0.3. So
took a while for TCP.
Yeah, exactly. There's no,
What
they are interested in this project. I don't know how much.
It wasn't one of the logos.
I don't remember.
Okay.
There's CERN is under which university?
CERN is
Yes. It's in a
Yeah, if you want to grab chairs.
only university.
Thank you.
It's fun. They only currently they're only university.